Have you ever stopped to wonder if we're truly alone in the universe? That question, which has intrigued humanity for centuries, has just gained a brand new chapter. Astronomers around the world are excited about the discovery of exoplanets that might, in fact, harbor life. And we're not talking about science fiction here. We're talking about solid data collected by cutting-edge space telescopes like TESS and the James Webb Space Telescope. These newly discovered planets are orbiting distant stars, located dozens, hundreds, or even thousands of light years away from Earth. What stands out is that some of these worlds lie in what's known as the habitable zone, a region where conditions could allow liquid water to exist on the surface. And as you probably know, where there's water, there's a real chance of life. What's even more interesting is that these planets don't only orbit stars similar to our Sun. Some of them are orbiting red dwarfs, smaller, cooler stars that are actually much more common in the universe. That significantly widens the range of possible life-friendly worlds. In this video, you'll discover the most promising exoplanets recently found, learn how these discoveries were made, and understand why they're causing such a stir in the scientific community. Get ready to travel with us across the cosmos and explore places that might, just might, be alive, even in ways we can't yet imagine. Before we talk about the most promising exoplanets, we need to understand a key concept. What exactly is the habitable zone? Simply put, the habitable zone is the region around a star where temperatures allow water to remain in liquid form on a planet's surface. Not too hot that it evaporates everything and not too cold that everything freezes. It's like a Goldilocks zone. Not too close, not too far from the star. But hold on. Being in the habitable zone does not guarantee that the planet has life. It simply means that, theoretically, it could have liquid water, and therefore, the basic conditions needed for life as we know it. Other factors are involved, such as the planet's atmosphere, presence of magnetic fields, geological activity, and even the type of star it orbits. That said, scientists use the habitable zone as one of the first filters to identify planets that deserve closer attention. Now that this is clear, let's look at some of the newly discovered exoplanets that are drawing attention precisely because they sit in this critical zone. And we'll start with one of the most talked about in recent months, Gliese 12b. Let's start with the most recent highlight, Gliese 12b. This exoplanet was discovered in 2024 and quickly caught the attention of astronomers around the world. Why? Because it's located just 40 light years from Earth, which, in cosmic terms, is practically next door. Gliese 12b orbits a red dwarf star called Gliese 12, which is smaller and cooler than our Sun. This type of star emits less radiation, meaning its habitable zone is much closer in. And that's exactly where Gliese 12b is located. It completes one orbit around its star in just 12 Earth days, meaning it's very close. But since the star is cool, that's not necessarily a problem for habitability. Early studies suggest Gliese 12b is roughly the size of Earth, with temperatures that could range from 10 degrees C to 50 degrees C, depending on the planet's atmosphere. That puts it among the most promising candidates for habitability so far. What scientists want to find out now is whether it has an atmosphere, and whether that atmosphere can retain heat and protect the surface from stellar radiation. The James Webb Space Telescope is already observing this planet, and soon we might have data on the composition of its atmosphere, if it exists. If water vapor, carbon dioxide, or even ozone is detected, it would be a major sign that the planet might support life-friendly conditions. But Gliese 12b isn't the only one on the list. Another fascinating system is TRAPPIST-1, which has 7 Earth-sized planets, and at least 3 of them lie in the habitable zone. This system is also about 40 light-years away and orbits an ultra-cool red dwarf star. What makes TRAPPIST-1 so special is that the planets are aligned in such a way that they're ideal for observation with modern telescopes. The most studied of the bunch are TRAPPIST-1e, 1f, and 1g. They have masses and sizes similar to Earth, and there are signs that some might have liquid water. However, we still don't know if these planets have protective atmospheres or magnetic fields. Because they orbit very close to their host star, there's concern about intense stellar activity, like flares, which could strip away any atmosphere they may have. Another planet scientists are keeping an eye on is K2-18b, located about 120 light-years away, orbiting a red dwarf in the constellation of Leo. What makes this world interesting is that it's classified as a super-Earth, meaning it's larger than Earth but smaller than Neptune. Observations from the Hubble Space Telescope have already detected water vapor in its atmosphere, and now, with the James Webb Telescope, researchers are looking for other organic molecules like methane and carbon dioxide. Even if these planets don't host intelligent life as we imagine it, the mere existence of stable environments with liquid water and complex chemistry would already be one of the most groundbreaking discoveries in scientific history. After all, proving that Earth is not unique in this sense would completely change how we see the universe and our place in it. Now that you've met some of the most promising exoplanets, you might be wondering, how do scientists even find planets that far away, especially ones we can't see directly? The answer lies in extremely precise and clever techniques that use the starlight itself to reveal what's around it. The first, and still most widely used technique, is the transit method. Here's how it works. When a planet passes in front of its star, from our point of view, it blocks a tiny fraction of the star's light. This causes a very slight dip in brightness, which can be detected by telescopes like TESS or Kepler. If that dip happens repeatedly at regular intervals, it's a strong sign of a planet. Based on how much light is blocked and how long the dip lasts, astronomers can estimate the planet's size and orbital path. Another important technique is radial velocity. In this case, scientists don't detect the planet itself, but rather the tiny wobbles in the star's motion caused by the planet's gravity. When a planet orbits a star, it also pulls slightly on the star, causing it to move back and forth. This movement shifts the star's light in a pattern known as the Doppler effect. By analyzing this shift in the star's light spectrum, researchers can calculate the mass of the planet and the shape of its orbit. And there's more. With atmospheric spectroscopy, used by the James Webb Space Telescope, we can study the composition of a planet's atmosphere. When starlight passes through a planet's atmosphere during transit, certain wavelengths are absorbed by molecules like water, methane, or carbon dioxide. These leave fingerprints in the light spectrum, a kind of chemical signature. This lets scientists detect elements that could point to conditions suitable for life. These combined techniques are revolutionizing our search for life beyond Earth, and the future looks even brighter. Upcoming telescopes like the ESA's Plato and NASA's Nancy Grace Roman Space Telescope will expand our ability to study small, Earth-like planets around nearby stars. With every new discovery, we move closer to answering the age-old question: are we alone? Maybe not. And for the first time, we finally have the tools to find out. When scientists search for signs of life on exoplanets, their main focus is to identify biosignatures, or chemical evidence that might indicate the presence of living organisms. These signs can be simple, like the presence of liquid water, or more complex, like molecules that can only be produced by living beings. The task is challenging, but with the advancement of technologies like the James Webb Space Telescope, detecting these signs, even on planets light-years away, has become a real possibility. The search for biosignatures begins with the molecules that make up the atmospheres of exoplanets. The most common and significant molecules for scientists are oxygen, O2, methane, CH4, water, H2O, and carbon dioxide, CO2. Oxygen, for instance, is an extremely interesting gas because, on Earth, it is produced in large quantities by photosynthesizing organisms, such as plants and algae. Its presence in large amounts could indicate that biological processes are occurring on a large scale. Although oxygen can be produced non-biologically, such as by photolysis, the decomposition of water by ultraviolet light, its combination with other chemical compounds like methane would be a strong indicator of biological activity. Methane is another important gas in the search for life. It can be produced by microorganisms that live in oxygen-free environments, such as those found in swamps or the intestines of animals. The presence of methane in exoplanet atmospheres could be a clue that biological activity is taking place. When methane is found in large amounts, especially when accompanied by oxygen, it strengthens the hypothesis that these planets may harbor some form of life. Water, in turn, is fundamental to life as we know it, and the search for signs of liquid Water in exoplanet atmospheres is a priority. Liquid water, in particular, is one of the biggest indicators that a planet could be habitable. Although an exoplanet may have water in the form of vapor or ice, it is liquid water that is considered essential for life. Planets with oceans or large bodies of water on their surface are ideal targets for the search for extraterrestrial life. In addition to these key molecules, carbon dioxide, CO2, also plays an important role in the search for life. On our planet, CO2 is a crucial part of the carbon cycle, which is vital for many biological processes. Its presence on an exoplanet, especially when detected alongside other gases, could be a sign that the planet has a stable climate, something that could be favorable for the development of life. Water, of course, is one of the most essential ingredients for life, and its presence in liquid form is a determining factor. However, beyond water, other factors such as temperature and atmospheric pressure must be favorable for the water to not evaporate or freeze. Even if a planet has the necessary conditions for liquid water, the temperature must be within an appropriate range for it to remain in its liquid state. For example, water might exist in liquid form, but on a planet that is too cold, it could freeze. Or on a planet that is too hot, it could evaporate. Therefore, the search for planets in the habitable zone of their star, where temperatures are ideal for liquid water, becomes one of the central tasks of astronomy. This concept of the habitable zone is crucial in the search for extraterrestrial life. The habitable zone is the region around a star where temperatures are mild enough for water to exist in liquid form. Planets located within this zone are more likely to harbor life, as liquid water is considered essential for biological processes. However, the exact position of the habitable zone varies depending on factors such as the type of star, its radiation, and the planet's atmosphere. Beyond water, the stability of an exoplanet's atmosphere is another critical factor in the search for life. A planet's atmosphere can act as a protective barrier against intense solar radiation and other cosmic hazards, helping regulate its temperature. The presence of a magnetic field is also an important sign. On Earth, our magnetic field protects us from the solar wind, preventing our atmosphere from being blown away into space. If an exoplanet has a strong magnetic field, this could indicate that it has natural protection, creating more favorable conditions for life. While many people think of the search for extraterrestrial life as seeking intelligent life, like the aliens we see in movies, the reality is that scientists are more focused on simple forms of life, such as bacteria and microorganisms. These organisms may not be visible to the naked eye, but their impact on the planet's chemistry can be detected. The detection of chemical compounds such as oxygen or methane, even in small concentrations, could be an indicator that simple life forms are present. Furthermore, even planets with a completely different chemistry from Earth could be habitable for life forms based on silicon or with atmospheres rich in ammonia or methane. These forms of life would be entirely different from what we know, but they could still exist, adapted to the local conditions. Therefore, when we talk about the search for life on exoplanets, we are not just looking for intelligent civilizations. We are investigating whether the conditions for simple life, such as microorganisms or primitive organisms, can exist on other worlds. And this is something revolutionary that could forever change our understanding of the universe and our place within it. Proxima b is an exoplanet located about 4.2 light-years from Earth, orbiting the star Proxima Centauri, which is the closest star to our solar system. Although it is distant, Proxima b's proximity to Earth makes it one of the most studied exoplanets and a primary candidate in the search for extraterrestrial life. This planet is roughly the same size as Earth, with approximately 1.17 times Earth's size and about 1.3 times Earth's mass. This suggests that Proxima b is a rocky planet, which increases the likelihood of it having a solid surface. The most interesting feature is that it lies within its star's habitable zone, also known as the Goldilocks zone. This is the region around a star where conditions might be suitable for the presence of liquid water, one of the essential components for life as we know it. However, the star Proxima b orbits is a red dwarf. These stars are much smaller and cooler than the Sun, meaning that the habitable zone around Proxima Centauri is much closer to the star compared to the habitable zone of our solar system. Proxima Centauri is also known for its intense stellar activity, with frequent solar flares and radiation fluctuations that could affect the stability of the planet's atmosphere. This poses a challenge to Proxima B's habitability, as these solar flares might be strong enough to destroy or push any potential atmosphere into space. The synchronous rotation of Proxima B, where the planet always shows the same side to its star, is another important factor to consider. This means that one side of the planet is permanently exposed to light, with extremely high temperatures, while the opposite side is permanently dark, potentially very cold. This temperature difference could create extreme conditions on the planet's surface, but the presence of a thick atmosphere could help distribute heat more evenly, creating more stable conditions. We still do not know if Proxima B has an atmosphere, but if it does, it would be crucial for protection against the intense radiation from its star. If it has a thick atmosphere, it could create a greenhouse effect that would help maintain milder temperatures on the dark side of the planet, allowing for the potential presence of liquid water and, potentially, life. The greatest interest in the search for life on Proxima B comes from the possibility of finding biosignatures, or chemical signs that could indicate the presence of life. Molecules such as oxygen, methane, or carbon dioxide are indicators that biological processes might be occurring. Although we have not detected these signs yet, future missions, such as the James Webb Space Telescope, will be able to study Proxima B's atmosphere in more detail, helping to identify these molecules and giving us a clearer indication of the potential for life. Additionally, the proximity of Proxima B to Earth is an advantage for future missions. Since it is relatively close to us, it may be possible to send probes or specialized telescopes to study the planet in greater detail, searching not only for signs of life, but also better understanding the physical and chemical conditions that could support simple life forms like microorganisms. In conclusion, Proxima B is one of the most intriguing exoplanets in our cosmic neighborhood. While there are challenges to overcome, such as its star's solar flares and the need for a stable atmosphere, Proxima B's conditions still make it one of the best places to look for signs of life beyond our solar system. It remains a key target in astrobiological research and our search for answers about life on other worlds. The search for signs of life continues, and who knows, in the future we might answer the big question: are we alone in the universe? If you enjoyed this video and want to learn more about the mysteries of space, don't forget to like and subscribe to the channel to keep up with more amazing discoveries. And of course, let us know in the comments what you think about the possibility of life on other planets. Let's explore the cosmos together.